Time is the silent architect of existence. It shapes every moment, commands every heartbeat, decides the birth of stars and the fading of their last light. We believe it flows like a river, steady, unstoppable, carrying the universe forward in a single, inevitable direction. Past, then present, then future. In order we trust, as if it were law written into the bones of reality yet. In the deepest layers of physics, that certainty begins to fracture, somewhere in the cosmos. A dead star seems to shine a little brighter each year, as if decay were reversing. In particle laboratories, fragments of matter behave like they remember decisions that have not yet been made. Quantum experiments reveal events unfolding backward, a cause following its effect. As if the universe were reading from the last page of the book first. If time has a direction, then why does it? And why must everything obey it? Humanity clings to memory as proof that the past is fixed. But what if memory is only a shadow cast by motion, and motion can turn around? Physicists now confront a disturbing possibility. The arrow of time may not pierce every corner of space-time. Perhaps across a cosmic horizon we cannot yet cross? Time moves the other way, a mirror universe where futures collapse into presents, and presents dissolve into pasts, if such a place exists. Then its inhabitants may be living through the consequences of our choices. Before we ever make them, a galaxy spins slowly in the darkness, each star a ticking hand of a celestial clock. But not every clock must agree, and not every story must begin before it ends. Before humanity learned to measure time, before the ticking of clocks and the counting of days, the world moved to rhythms no one yet understood. The rising of the sun, the beating of hearts, the aging of bodies. Time revealed itself only through change. Ancient philosophers looked at this forward motion and imagined time as an invisible companion, walking beside existence. Sculpting destiny, Aristotle believed time was the measure of motion, inseparable from the movement of objects. Without motion, he said, time would not exist at all. St. Augustine disagreed, seeing time as something deeper, an internal experience shaped by memory and anticipation. To him, the past survived only in the mind, and the future existed merely in hope. For both, time was intrinsic to reality, not a choice, but a condition of being. These reflections shaped early understanding for centuries. Time was taken for granted, like breath, like sunlight. It did not need explanation. It simply was. But human curiosity refuses to let comfort remain unchallenged. And a new era rose, one defined by measurement, by mathematical certainty, by the aspiration to master nature. In this new world, a mind emerged that would redefine time forever. Isaac Newton envisioned time as a grand stage on which the play of the universe unfolds. Whether or not anything happens, the stage remains infinite, absolute, untouched by the motions within it. Time, in Newton's cosmos, ticked the same everywhere. The fall of an apple in England and the orbit of a moon around Jupiter were both governed by the same unchanging clock. Newton's vision felt perfect, elegant, rational, empowering. It became the foundation upon which centuries of physics were built. Yet beneath its simplicity lay a quiet fragility. If time is absolute, why does motion bend? Why should gravity distort paths while time remains pristine? That question remained silent until a clerk in a Swiss patent office decided to listen. Albert Einstein shattered the comfortable illusion by showing that time is not a background, but a participant, not a stage, but a dancer. In his theory of relativity, space and time intertwine into a single entity, space-time. Gravity does not pull, it curves the very geometry through which time flows. A clock orbiting Earth ticks differently from one resting on the ground. A traveler moving fast through space experiences fewer seconds than one standing still. Time, suddenly, became personal. Einstein's equations revealed a possibility that was deeply unsettling. Time's flow is not universal. Each observer carries a different rhythm. Clocks disagree, not because they malfunction, but because the universe demands they do. And yet, despite this revolutionary insight, one comforting principle still seemed untouched. Time moves forward. Even relativity bowed to the familiar arrow of past gives present gives future. That assumption would not survive the subatomic age, midway through the 20th century. Physics looked deeper beneath atoms, beneath the structure of matter, into the quantum chaos, where rules of intuition dissolve. Their particles flicker into existence and disappear again. They exist in multiple states at once. They ignore deterministic paths and obey the logic of probability. At this tiny scale, the universe begins to ask dangerous questions. If the laws of physics treat time as a directionless dimension, like forward or backward on a map, why should nature prefer one direction over another? Why should time not be reversible, just as position is? This thought evolved into a principle called CPT symmetry, a fundamental rule suggesting that if matter were replaced by antimatter, and space were mirrored, and time were reversed, the laws of physics should remain unchanged. Nothing in the mathematics demanded that time must move forward. Forward time, it seemed, might be a preference, not a rule. Then came an experiment that shook the foundations of science. In 1964, physicists James Cronin and Val Fitch studied neutral kaons, strange particles created in high-energy collisions. These kaons occasionally decayed into other particles, but something unusual happened. Their decay rates were not perfectly symmetrical. They behaved differently than their antimatter counterparts. The result was tiny, almost imperceptible, but undeniable. Universe was breaking the mirror. Cronin and Fitch had discovered CP violation A, violation of charge and parity symmetry, meaning matter and antimatter do not always follow identical rules. And if CP symmetry breaks, then T symmetry, time reversal, must break too. The conclusion thundered through every corner of physics at the quantum scale. Time does not always flow the same way forward. This was the first crack in the illusion of a single temporal direction. A quiet but seismic realization: the universe knows how to move backward. Kaonas. These microscopic entities that exist for mere fractions of a second had revealed something unimaginable, that the fundamental laws of nature do not strictly enforce the arrow of time. Scientists found themselves staring into a paradox. Everything experienced in the visible world suggests time must always progress forward. Yet the building blocks of that world insist the opposite is equally valid. Which is true? The reality we live in, or the one hidden beneath it? Physicists tried to push the confrontation aside at first. It was easier to believe time reversal occurred only in rare particles in special conditions, not in the universe at large. But the seed of doubt had already been planted. If particles could ignore the arrow of time, then somewhere under different conditions, entire systems might do the same. The discovery of CP violation forced science into an uncomfortable corner. Time had become a negotiable property influenced by physical context, vulnerable to symmetry shifts, altered by the presence of mass acceleration, or quantum environment. Time, once a postcard of certainty, was now a puzzle scattered across the floor of human understanding. As observations improved, new anomalies emerged. The early universe appeared strangely uniform, too smooth, synchronized, as if information had traveled faster than light or backward through time to even out the chaos. Dark energy began accelerating the expansion of the universe in a way that hinted not at decay, but at a reversal of entropy on massive scales. Even the cosmic microwave background, the ancient afterglow of the Big Bang, seemed to whisper secrets about temporal symmetry, as if the universe's first breath was shared by two expanding realms, one moving forward, one moving backward, both racing away from the same explosive origin. Each shift in scientific perspective drew the same question closer. What if our direction of time is not universal? What if forward is just our point of view? The philosophical implications returned, more powerful than ever. Augustine's paradox resurfaced. If the past lives only in memory, and the future only in expectation, then time itself might be an illusion, a construct of consciousness, a lens through which the brain interprets change. Yet change is real. Decay is real. Aging is real. Stars are born, burn and die, and none of them retrace their light. Or do they? Some stars deep in the cosmos appear too young for their age. Their structures exhibit entropy levels that look like they are evolving in reverse. Entire galactic regions show perplexing energy distributions that suggest time may not flow uniformly across distances. What began as philosophy became mathematics. What became mathematics became experiments. What became experiments became doubt. Doubt that time is unbreakable. Doubt that our story must always go forward. Doubt that certainty is anything more than a comfort. The evolution of our understanding has led us here to a mystery with roots stretching through centuries of belief, discovery, and disbelief. From Aristotle's reflections to Newton's absolutes, from Einstein's curved spacetime to quantum reversals, the universe has slowly peeled away the illusion of temporal simplicity. Time no longer stands as a silent ruler of existence. It has revealed itself as fragile, flexible, flawed. A question now lingers, one that has transcended theory and entered the realm of necessity. If the microscopic fabric of reality can run backward, then what prevents the macroscopic universe from doing the same? This is not merely a story about physics. It is a confrontation with the limits of meaning. With the edge of what it means to exist, the universe has begun whispering a terrifying possibility. That forward is only a habit, and habits can break. And if there is a corner of creation where time has chosen a different direction, it may already be traveling toward us. For centuries, the universe appeared obedient to a principle so familiar that humanity rarely questioned it. What is broken does not mend itself. What ages does not grow young again. What dies does not return to life. This principle has a scientific name, the arrow of time, and it points forward. Forward toward decay. Forward toward disorder. Forward toward the inevitable unraveling of everything. This arrow is defined by entropy, the gradual increase of chaos in every system. Ice melts into water, which evaporates into air. Stars burn fuel, collapse into embers of light, and fade into the quiet dark. Human beings accumulate memories and lose days that never return. The world changes in irreversible ways, and that irreversibility is what makes the future different from the past. Entropy is time's direction. Yet as experiments revealed cracks in this rule, a frightening thought emerged. What if entropy is not the universal law we believed it to be? What if time does not always choose to move forward? This possibility, once unthinkable, began to corner physics into a paradox. If a region of the universe exists where entropy decreases, then from that region's perspective, we are the ones moving backward. Our past might be their future. Their future, our past. Causality, the chain linking cause to effect, becomes unmoored. A glass shatters on the floor because gravity pulls it down. Not because shards choose to reassemble into a drinking vessel. But if time reversed, effects could precede causes. A star might absorb its own supernova and revert to youth. A life could end before it is ever born. Reality would feel like a film running in reverse, not because the film was altered, but because the projector demands a different direction. And yet the laws of physics, when written into equations, do not forbid this. The horror does not come from mathematical inconsistency. It comes from the sudden loss of meaning. If time lacks a universal direction, then nothing guarantees the story of existence is coherent everywhere. Life evolved because time moved forward, allowing complexity to rise. Memory exists because events leave traces that endure. Civilization stands because history builds, layer upon layer, toward knowledge. But a universe where time may reverse threatens all of it. If time can run backward, then memory becomes unreliable, change becomes optional, progress becomes illusion, worst of all. Causality becomes a matter of perspective. What humans call destruction, entropy blooming outward could be. For another form of life, the beginning of structure, of order, of identity. For them, stars exploding may feel like Genesis. Civilizations collapsing may feel like dawn. The terrifying implication is this: there may be observers intelligent, conscious observers for whom the story of humanity has already unfolded. backward. They may already know how our world ends, because to them, that ending has already happened. They may be watching Earth's distant future, perceiving it as their distant past. Our beginning, our first flicker of life may be to them an echo of something already forgotten. These possibilities do not simply threaten physics. They threaten psychology. Human purpose is built on the notion of forward motion, forward growth, forward destiny, if forward is not universal, and purpose dissolves into uncertainty. What does it mean to evolve if another universe watches evolution reverse? What does it mean to learn if knowledge could someday unwrite itself? What does it mean to exist if existence can shrink back into nothingness? Imagine a civilization in reverse, remembering the outcomes of wars before they begin, mourning the loss of stars before they are born, grieving the ruin of worlds that have yet to flourish. Their children would grow younger with each passing day. Their dead would rise from ashes only to become infants. Their history books, if such things could exist, would document a future that vanishes one breath at a time in such a place. Survival would be a countdown. Existence would be an unraveling. Destiny would be decay, the old becoming new until the new becomes nothing. And if our timelines touched, which one would overpower the other? Humanity looks into the mirror of physics and sees a disturbing truth. Our certainty is fragile. The belief that time is moving us forward is not guaranteed by nature. It is merely observed here, where entropy increases. If entropy can fall elsewhere, then forwardness is a local phenomenon, like weather or dialect. Time could have dialects. Two different directions spoken in different regions of space-time. If such regions exist, the Big Bang becomes a boundary, not a beginning, separating two realms, where time flows away from that primordial moment in opposite directions. We may be advancing from that explosion. While others retreat toward it, Earth's chronicles could be nothing but reconnaissance data gathered long after events conclude in a timeline already collapsing. If those beings look outward, they might see our future stretching behind them like fading starlight. Humanity stands atop a fragile pedestal of assumptions. The second law of thermodynamics, entropy, has long been the pillar keeping purpose intact. Remove that pillar, and what remains? Order becomes negotiable. Progress becomes reversible. Life becomes temporary in a new and terrifying way, because if entropy can decline, so can existence itself. And what then becomes of memory? If effects can precede causes, memory may not record what has happened, but what will happen. Déjà vu may not be a glitch, but a glimpse into events unfolding in reverse across the quantum fabric. If time reversal is real, the future may already know us, and the past may still be deciding whether we ever existed. The more science confronts this possibility, the heavier the dread becomes. Not dread of doom, but dread of erasure. Not fear of death, but fear of unbecoming. Every discovery that challenges the arrow of time forces humanity to ask questions it is not ready to answer. What if identity does not survive time reversal? What if meaning dissolves when history unravels? What if our existence is only temporary direction? We build monuments to resist forgetting, libraries, data servers, digital clouds. But if a reversed timeline merges with ours, knowledge could unwrite itself. It is not the apocalypse that should frighten us, but the possibility that our achievements could quietly fade into infancy, then into silence. Time reversal is not a scientific curiosity. It is an existential earthquake. It tells humans, you are not guaranteed a future. You are barely guaranteed a past. Physics does not owe humanity comfort. The cosmos does not promise continuity. Time does not swear allegiance to progress. Somewhere in space-time, there may be life walking backward into its birth, watching galaxies contract into points, watching creation collapse into a singular origin that will someday vanish altogether. And we, in our direction of time, may be marching toward them, toward a collision of arrows, toward a confrontation between two incompatible histories. One story will erase the other. This is the scientific shock. Time, the most familiar force of existence, may be the least understood. And if its flow can change, so can everything built upon it. As the shock of possibility spread through science that the arrow of time might not be universal, the response was not denial. It was curiosity. The universe had opened a forbidden door, and humanity, driven by the instinct that discovery must continue, stepped closer. The search for answers pushed scientists deeper into the quantum realm, into laboratories where particles behave like riddles, capable of rewriting what reality means. Quantum entanglement had already defied common sense. Two particles, separated by vast distances, responded to changes as if no space existed between them. Instant communication that seemed to ignore time itself. But then came experiments that bent the mind even further in the delayed choice. Quantum eraser, an experiment, rooted in the ideas of physicist John Archibald Wheeler. The decision of how to measure a particle in the present influenced how that particle behaved in the past. The particles seemed to wait for a future choice before deciding what it had already done. Cause and effect traded places. The universe looked backward. Before moving forward, some physicists called it retrocausality, effects shaping causes, not the other way around. Others dared to suggest that time in the quantum realm might be two-way, traffic that particles can explore the future before committing to a past. What happens in the quantum world should stay in the quantum world. But it did. Astronomy began showing signs too, signs visible across billions of light-years galaxies. It's formed too quickly and too smoothly in the early universe, like structures guided, not chaotic. Their entropy patterns did not match what forward-moving time should have produced. They appeared pre-organized. It was as though they were developing with knowledge of what they were destined to become. Some cosmologists whispered a taboo idea. These galaxies looked like they were evolving backward. Observations from telescopes and cosmic microwave background maps revealed hints of anomalous regions, zones where gravitational patterns imply entropy flows that don't match predictions. Something, somewhere, was resisting the march toward disorder. And then came evidence from expansion itself. The universe is growing, stretching faster and faster. Dark energy fuels this acceleration. But certain models of inflation, the rapid expansion that occurred in the moments after the Big Bang, suggest something extraordinary. The expansion might not be identical in every temporal direction. Some simulations show negative time solutions, where pockets of space-time do not expand forward like ours, but backward. As if the universe had split at birth, one half unfolding into the future, the other collapsing into a future past. A mirror cosmos, not beside us, but behind us. This radical view became known as the Janus point theory, named after the two-faced Roman god of beginnings and endings. Nobel Prize-winning physicist Sir Roger Penrose proposed that the Big Bang could be a central point of time symmetry, where time flows outward in opposite directions. One universe, moving forward in time, a reflection, moving backward, both expanding away from the same cosmic origin. In this vision, the Big Bang is not the start of a timeline. It is the middle. A temporal explosion, two arrows piercing reality in opposite directions, both carrying memories that do not yet exist. The deeper scientists searched, the more the universe seemed to hint that time reversal wasn't just theoretical whimsy, it was coded into physics. But evidence brings questions, and questions bring fear, because if such a mirror universe exists, if time truly flows backward elsewhere, then what connects these twin realms? Could information travel between them? Could energy cross that boundary? Could causality leak? The world's most sensitive neutrino observatories, IceCube in Antarctica, and subterranean detectors scattered across the planet began noticing whispers from a direction physics couldn't explain. Signals rising up from Earth, not falling down upon it. NASA's Anita experiment detected particles emerging from the ground, energies that should have destroyed their existence long before. They behaved as if they had memory of paths that ran opposite to ours, not particles arriving from space, but particles arriving from another time, a reversed world leaving fingerprints upon ours. Some physicists argued caution. Perhaps new physics was needed, undiscovered particles, misinterpreted interactions, experimental anomalies. But mathematics refused to quiet the suspicion. Every equation that allowed time, symmetry to hold true demanded one haunting possibility. Reverse time is not an exception. It is a perfectly valid version of existence. The deeper these investigations went, the more blurred the boundaries became between physics and destiny, between science and something almost mythic. If time can reverse, then the future is not guaranteed to stay ahead of us. If entropy can fall, then meaning is not guaranteed to accumulate. Life feels purposeful, because existence flows from ignorance toward understanding. But reverse time suggests a universe that forgets, that collapses complexity into simplicity, that unbuilds itself into silence. So scientists pushed further, desperate to know, are these hints signs of a real temporal divide? Or are they illusions created by mathematics trying to simplify a chaos too large for human comprehension? Is backward time a physical truth? Or a mirage that disappears once we approach? The more instruments revealed, the less certain anyone became. What does entropy mean? If some galaxies refuse to obey its growth, what does causality mean? If quantum choice can ripple backward, what does existence mean? If another existence traces the opposite direction, and what of consciousness? If time's direction is not fundamental, if the brain's perception of time is an evolutionary adaptation, not a universal truth, then memory, identity, and purpose might simply be biological interpretations, a survival mechanism of forward-time creatures like humans, but backward-time life, if it exists, might perceive history not as foundation, but as destiny, not as memory, but as prophecy. Their experience of existence would be fundamentally inverted, not because they misunderstand time, but because we do. Physicists stare into equations that whisper unsettling meanings. There might be civilizations unlearning what they once knew, stars returning to fuel, atoms decomposing into quarks, beings growing younger, shedding knowledge into innocence, collapsing slowly into origin and into nothing, and in the quiet between observations. A deeper question: what if reverse time is not separate from us, but touches us every moment in the silence of the quantum world? What if entangled particles keep both directions alive, carrying dual histories that meet only during observation? What if time is not a line, but a conversation? Forward asks, what will be? Backward remembers what was chosen. Every discovery compounds the confusion. Galaxies that seem to wise, quantum particles that hesitate before deciding their past, signals that rise out of impossible directions. A universe whose beginning might be the midpoint. Science stands uncertain at a horizon of understanding, unable to see what lies beyond. Yet unable to look away, experiments alone cannot answer the ultimate question: is reverse time real? Or have we misunderstood what time fundamentally is? Perhaps humans are too deeply embedded inside the forward arrow to notice its limits. Perhaps our perspective is the illusion. The cosmos hides its deeper symmetry well, like a mirror perfectly polished, reflecting nothing unless viewed from the correct angle. Maybe time itself is that mirror, and we are standing too close to recognize our own reflection staring back. The deeper the investigation goes, the more frightening the possibility becomes. The arrow of time is not universal, but time without a universal arrow is a universe without guarantee, a universe where the story does not need to make sense, where the end is not obligated to follow the beginning, where existence may already be unspooling in reverse quietly, invisibly, waiting for its moment to converge with ours. And when those arrows meet, which direction will survive? The deeper science descends into the architecture of time, the more the universe begins to feel like a contradiction, a place where rules hold firm only until reality decides otherwise. Time, once thought simple and obedient, now appears fractured. Its arrow, which should point unwaveringly toward the future, bends, twists, and in some hidden corners, seems to turn around completely. No object in the universe challenges. It's more fiercely than the black hole. Black holes are factories of entropy, cosmic furnaces where matter, energy, and information are torn apart and swallowed into a darkness from which not even light escapes. According to the second law of thermodynamics, they must grow in entropy as they feed. They are the ultimate consequences of time's forward motion. Everything they capture becomes part of their irreversible fall into disorder, but every rule begs its opposite. In physics, with a quiet yet insistent whisper, answers with a haunting possibility. If a black hole exists, then so could its inverse. A white hole, an object theorized to behave as a black hole in reverse, ejecting matter and energy instead of consuming it. A place where nothing can fall inward and everything must be expelled outward. Such a creature could only survive if time inside it flowed backward, rewind instead of record, unwitnessed by any observer tied to the forward arrow. What would such an object look like? Would it be a star uncollapsing? A singularity unraveling its secrets? A wound in space-time healing itself? White holes remain hypothetical, yet their existence would complete a symmetry the universe often seems desperate to maintain. Nature rarely allows a one-sided story. For every charge, an opposite charge. For every motion, an opposite direction. Why not, then, for time itself? This symmetry deepens another mystery already underway, the accelerating expansion of the universe. Dark energy pushes galaxies apart faster and faster, as though space were being stretched by an invisible hand. But what if that hand belongs not to our timeline, but to a mirror one? A timeline pulling space forward from its perspective and backward from ours. Some cosmologists have proposed that the source of dark energy could be temporal interaction, a hidden influence from the universe, where time flows in reverse, a push and pull between two realities, drifting apart since the very beginning, which raises the most disquieting possibility yet. The separation point, the barrier between the two arrows of time, may be the Big Bang. Itself, not the beginning of everything, but the middle of a larger symmetry. If the Big Bang was the instant where time's arrow split into two opposite directions, then we are not alone in our journey away from origin. Another cosmos has been traveling just as long, not ahead of us, but behind us, though the distance grows larger in every moment. Imagine two universes, back to back, expanding into their futures, which are each other's pasts. Our stars are growing older. Theirs are growing younger. Our galaxies stretch outward as they evolve into complexity. Theirs slip inward as they dissolve into simplicity. Their physics remembers the future. Ours remembers the past. It is the kind of symmetry that is too elegant to dismiss and too disturbing to ignore in that universe. That reversed realm might not be devoid of life if consciousness emerged there. It would grow in the direction of unlearning. Minds would awaken with full knowledge of their civilizations, only to shed that knowledge piece by piece, like pages torn from a book and cast into the void. Language would erode into instinct. Technology would crumble into raw materials. History would scatter into forgotten starlight. They would watch their greatest achievements disappear, not in destruction, but in unraveling. For them, the birth of a star would be a death, and the death of a star, a rebirth. Everything they build, cities, sciences, culture, would eventually fade, until the universe around them returned to original simplicity. Until the last atom came undone, returning to a primordial state, until they reached the Big Bang, and vanished into beginning. In such a universe, death is not an end. Birth is not a beginning. Everything purposeful becomes meaningless in reverse. If beings like this exist, what do they dream of? What do they fear? Do they look across the cosmic divide toward us, witnessing a world they can never reach, a world moving away from their own horizon of existence? Or are they unaware? For memory dies as quickly as it forms. For humans, the thought alone unravels comfort. Purpose feels fragile. Progress feels temporary. Achievement becomes a suspect illusion, because if the universe contains two stories, traveling in opposite directions, what does that make ours? Just one half of a truth. An incomplete history, a narrative without guarantee. The existential dread intensifies, not because the universe is cruel, but because it is bigger than comprehension. We were taught that time is the most constant companion, the guide that ensures life moves from chaos into wisdom. But if backward time is real, then wisdom itself may be reversible. The laws we believe sit at the foundation of reality. Thermodynamics, causality, entropy begin to feel less like laws and more like regional customs. Gravity does not care what humans expect of it. Neither does time. For every scientist who insists that backward time is mere abstraction, there is an equation defying that certainty. For every philosopher who argues that existence needs direction, there is a particle behaving as though direction is optional, and the growing body of evidence refuses silence. Black holes may hide time reversal behind their horizons. White holes may exist as ejectors of forgotten futures. Dark energy may be tension between two opposing temporal flows. The Big Bang may be a meeting point, not a start. Another cosmic civilization could be unmaking its way into oblivion. Not one of these ideas proves the other. Yet together, they form a pattern impossible to ignore. The universe may not be a line. It may be a forked two paths diverging from the same explosive moment, never destined to touch again. Unless they do, the greatest fear humanity has ever known is death, the end of the individual story. But reversing time reframes fear into something darker, the end of the collective story, the unraveling of humanity's achievements, the erasure of every footprint in the sands of time. If the twin universe's entropy decreases, pulling it closer to the Janus point, its gravitational and quantum influence might someday brush against our world. Not a collision of matter, but of direction. Two arrows striking tip to tip. Two histories grinding against each other. Two beginnings meeting in the middle. Which direction would dominate? Would the entire universe choose to move forward or backward? Which story would remain remembered? Which would dissolve into unborn dreams? Scientific progress demands courage. The courage to face truths that do not comfort. The deeper physicists look, the more they realize that the most fundamental question is not, what is time? But why does time choose a direction? And what if it chooses differently tomorrow? For now, humanity continues advancing, hopeful that meaning grows the longer the arrow stretches. Meanwhile, others, if they exist, continue collapsing into their own horizon, losing meaning with every step. Two universes, two destinies, both valid, both real, both inevitable. Their story may be our reflection. Our story may be their echo. The cosmos is not a single narrative. It is a dual memoir, two tales diverging from a shared beginning, forever separating into futures that belong to opposite arrows of time, and somewhere far beyond the edge of what humans can observe. The backward universe is still unbuilding its way toward us. As the mystery of reverse time deepens, science faces a crossroads. The clues gathered across quantum behavior, cosmic evolution, and entropy defiance have become impossible to ignore. The universe speaks in patterns, and it speaks with purpose. But understanding that purpose requires more than observation. It requires interpretation. Theoretical physics is where evidence transforms into possibility, where equations reveal dreams, where the invisible becomes imaginable. And so, the most daring thinkers began building models of a cosmos that does not obey the comforting simplicity of a one-directional story. Their theories do not agree with each other, but they agree on one haunting truth. What is backward for us may be forward for someone else. CPT symmetry, a reversible reality. The heart of many theories lies the CPT symmetric universe model. It's an answer born from mathematics that refuses to break. If three properties, charge, parity, and time, flip together, physics remains unchanged. It is a rule so fundamental that if time did not reverse under symmetry, the universe itself would lose consistency. This led scientists to propose a bold scenario. Instead of one universe expanding forward from the Big Bang, there may be two. Two universes born at the same moment. Mirror twins. Ours, where matter dominates and time flows forward. Its reflection, where antimatter dominates and time flows backward. Where we see decay, they see rejuvenation. Where we see aging, they see arrival. Each universe maintains the symmetry denied to the other. If we tried to visit their world, time would feel hostile, forcing our atoms to unlive, unbind, and unwind to them. We are the reversed ones. Branching timelines, a multiverse of directions quantum mechanics, refuses to choose a single outcome. It allows everything possible to occur. But in different branches of reality, the many worlds interpretation suggests every choice the universe makes splits reality into diverging timelines, infinite versions of existence, each with its own unfolding narrative. But quantum gravity, time as an illusion, the further science ventures into the quantum heart of gravity, the less stable time becomes. Some of the most profound theories in physics, including loop quantum gravity, propose a shocking idea. Time may not be fundamental, not a dimension, not a river, not a thing, but an emergent illusion, a sensation born from change. Rocks erode, stars ignite, cells divide. Brains remember, change creates the illusion of time, and consciousness clings to the illusion. If there is no time, there can be no direction. Forward and backward are merely interpretations, how certain observers organize experience in such a universe. Time reversal is no stranger than walking backward. It is simply a different path. Backward is only confusing because humans evolved in a world where entropy grows, not because backward is impossible. Entropy is a choice. Time. From disorder, entropy governs what we call time's arrow. As disorder increases, the future reveals itself. Entropy rises, and the story moves on. But what if entropy is not absolute? In regions where entropy decreases, where order strengthens over time, the arrow flips. The future becomes the past. Evolution becomes devolution. History becomes foreshadowing. Entropy does not exist to enforce. Time exists to describe entropy. If the universe chooses order, time follows. If the universe chooses chaos, time follows. Time is not leader, it is follower. And if two places in the cosmos choose differently, then two times exist. Penrose's Eternal Symphony, Universes in Cycles, Sir. Roger Penrose offers a vision almost poetic in its magnitude. In conformal cyclic cosmology, the universe is a symphony of eras, eons. Each beginning where the last one ends. When the universe becomes pure radiation, no matter, no structure, no clocks, time loses meaning. In that instant, the universe smooths into something akin to the beginning of another. Big Bang. The death of one cosmos becomes the birth of the next. But why must the new universe share the same direction of time? Penrose suggests it doesn't. Entropy resets not by returning, but by redefining. The arrow begins anew, but not necessarily pointing the same way. Imagine a string of universes, like beads, each bead a life from birth to silence. Each connected but not aligned, some arrows forward, some arrows backward, all valid. All real. We may live in the 6th or 7th era, not the first. Our beginning is someone else's ending. Our ending will become someone else's dawn, and they may walk opposite our path, an eon in reverse. Relational time, only local clocks. Exists the philosopher Gottfried Wilhelm Leibniz argued something far ahead of his era. Time has no existence without the objects inside it. There is no master clock. No universal ticking pulse. No single rhythm for all of reality instead. Time is relational, defined only by how events interact. If the rhythm of existence can change from one region to another, if clocks disagree because space bends or moves, then nothing forces any region to share a direction. Human time is local. Cosmic time is vast. Reality may not require them to agree. In one sector of space-time, entropy might rise. In another, it might fall. Each region builds its own time. Each region builds its own history. No version is more true than the other. Terrifying consensus, each theory, different in approach. Mathematics and worldview converges upon the same conclusion. Time has more than one direction. Forward is no more universal than up or north. The cosmos may be filled with travelers walking backward into creation, and they see themselves as the ones progressing what feels catastrophic. Two humans, civilizations crumbling into ignorance. Stars collapsing into gas may feel like birth to them, what we call evolution. They may call loss. Each perspective correct in its own temporal frame. The universe does not care which direction hearts beat. The universe only insists that existence continues. We are not witnessing the failure of physics. We are witnessing the widening of what physics can hold. Humanity stands on a fragile ledge of understanding, staring into a vista where the familiar dissolves. We once thought the universe was one story. Now, theory whispers something darker. It is two stories written in opposite directions. By the same beginning, our time flows outward like breath. Theirs flows inward like memory. Somewhere a galaxy unforms, not dying, but returning. Somewhere, a star unburns its hydrogen, not collapsing, but preparing to be born. Somewhere a mind forgets tomorrow, because tomorrow has already happened. Forward and backward are not opposites. They are partners in symmetry. Two halves of a greater truth, and humanity is left with a question from which there is no comfort. If backward time is rising, how long before it meets us? As the universe continued to reveal cracks in the certainty of time, a new phase of exploration began. Theorizing alone was no longer enough. Humanity needed instruments, machines capable of touching the secrets woven into the cosmic fabric. Only through measurement could truth emerge from speculation. And so, the greatest observatories ever built now stand as sentinels against the unknown, not searching for stars, but for direction. The direction of time. The James Webb Space Telescope peers deeper into the past than any instrument before it. With mirrors unfolding like golden petals against the cold, JWST observes the first galaxies that emerged after the Big Bang, places where the arrow of time should be clearest. Yet what it sees is unsettling. Structures to mature in a universe. Two young stars, heavy with metal far earlier than should be possible. Entropy patterns that do not climb smoothly upward, but ripple as if some regions evolve with knowledge of what they are destined to become. JWST forces a quiet fear. Maybe the early universe was not a blank slate, but the midpoint of two opposing time flows. Meanwhile, beneath mountains and far underground, experiments try to capture the smallest hints of symmetry breaking. At CERN's Large Hadron Collider, annihilation of matter and antimatter continues. Like a drumbeat testing the rhythm of the universe, every collision asks the same silent question: if time truly reverses in antimatter, will it confess under pressure? Physicists study the slightest differences, charge, decay, oscillation, hoping to detect where time disagrees with itself. A single asymmetry in antimatter behavior could be the fingerprint of backward time, a direction invisible to human eyes, but undeniable to mathematics. Yet while some instruments stare into the smallest scales of existence, others listen for whispers from the deepest dark. The Ice Cube Neutrino Observatory, frozen into the Antarctic ice sheet, waits for particles that should not exist, neutrinos, moving upward through Earth's core when physics insists they must come from the sky, and they do arrive. Signals. With energies too high to survive the journey, particles that emerge from rock as if they traveled through a tunnel not of space, but of time. To explain them requires something unimaginable. They may be coming from a universe that runs backward, above the ice. NASA's mission Anita drifts on the polar winds, antennas poised like ears against the void, listening for radio bursts created by impossible particles. When such pulses are detected, they paint a picture not of cosmic rays descending, but ascending, as though their journey began in Earth's own future. Elsewhere in Japan, Super Kamiokande, a cathedral of pure water and sensitive light detectors. Searches for interactions that defy the arrow of time. Every flash of Cherenkov radiation might hold a story that is already concluded. Elsewhere, scientists do not speak of these results with excitement. They speak with restraint, with caution, with awe, because each anomaly forces the same conclusion closer, somewhere in the quantum haze of reality. Time is disobeying at laboratories around the world. Researchers working in quantum communication push retrocausality to the edge of believability. Entangled particles exchange information instantly, without regard for sequence. Changing the future measurement changes the recorded past. Timelines converge like braided threads, twisting into one another, blurring what before and after even mean. If information can travel backward, even by a fraction of a second, then the past is negotiable. And if the past is negotiable, then destiny becomes a variable in the void between galaxies. Still another tool listens, one built not to observe particles or photons, but the very movement of space-time itself. Gravitational wave observatories, LIGO, Virgo, Cagra, hear the trembling of the cosmos when stars collide and black holes merge. Those waves ripple not only through space, but through time. Researchers now analyze whether some distortions arrive before the events that cause them. Whether space-time knows what is coming before the universe does. Every new detection adds another uncomfortable question to humanity's growing list. Can space-time echo events in reverse? Do black holes release signals backward across the years they consume? If a star collapses in the future, could the waves of its death reach us today? If so, then the future isn't just predicted, it may be felt. All these instruments, JWST, LHC, eScoob, ANITA, Super Cameo Condi, LIGO, form a network of reality checkers. They attempt to measure a universe that refuses to behave, but there lies the true challenge. How do you study a universe whose secrets hide in a direction you are not allowed to face? Every detector built by human hands works under the assumption that time flows forward. But backward time would not reveal itself in familiar ways. Signals arriving too early might be discarded as noise. Patterns that appear reversed might be deemed errors in calibration. What if the proof has already been found and misunderstood? Scientists now wrestle not only with cosmic mysteries, but with the limitations of human intuition. If a message arrived from the past that has not happened yet, would anyone know how to read it? What would such a message look like? Would it speak in light, in gravity, in particles cutting against causality? Or would it appear as déjà vu, a memory from a future we have not lived? And if communication is possible, what would a backward universe want to say? Perhaps nothing. Perhaps everything. Maybe their physics is warning us that our timeline is not the only story, that our arrow is not the only direction, that our fate might someday meet theirs. The greatest tools of science now point at this singular unknown. And physicists, standing at the edge of comprehension, ask questions that sound like poetry in the language of fear. Can a backward universe see us coming? And can we see it leaving? If these timelines converge, if the arrows collide, will existence choose a direction? Or will direction collapse into chaos? For the first time in history, humanity is reaching not outward, but beyond, through the silence between seconds, searching for the answer to a question older than consciousness. Is time truly leading us forward, or simply allowing us to believe it does? The tools are in place. The signals are whispering, and the cosmos waits not for discovery, but for understanding. Time has always been humanity's most intimate companion and most elusive mystery. It shapes identity, structures memory, and gives purpose to every breath. To live is to move forward, toward experiences not yet lived, toward choices not yet made. The future is the horizon that pulls existence onward. But now, the universe whispers that time may not be faithful to direction. It may not even be faithful to meaning. If time can move backwards somewhere, then existence is not a march, but a question. a question with no guarantee of one answer. Humans believe life is a journey, because journeys suggest progression, motion from innocence to wisdom, from birth to purpose, from origin to finale. But a backward universe reveals something unsettling. A journey can be reversed. A story can be unread. A purpose can be unmade. If time can negotiate its direction, then life becomes fragile, not because death looms ahead, but because the idea of ahead becomes uncertain. Memory, the anchor of identity, may be nothing more than a habit of the brain, a convenient illusion of continuity, a biological trick to navigate a universe whose truth is stranger than imagination. If memory is optional, then who are we when it fades, or when it forms in the wrong direction? In a backward-flowing world, knowledge would not accumulate. It would erode. A mind would awaken with the full weight of its history, and lose it piece by piece. Each second, a lesson forgotten. Each hour, a skill dissolved. Each day, a life, UNLEAR. Wisdom would be a myth. Experience a countdown. Identity, a temporary shape. We believe progress is growth, that strength, civilization, and understanding rise with time. But if decay is not destruction, if it is merely birth in reverse, then evolution is only one option. Perhaps the universe does not celebrate complexity. Perhaps it tolerates it, briefly, before asking existence to simplify again. If time can reverse, then death may not be the final moment. It may be the first step, a return to possibility. And birth so sacred to human meaning may be the final release. The last moment before all stories dissolve into the silence of potential. Humans cling to forward time because it aligns with hope. Backward time aligns with inevitability. Forward time builds. Backward time undoes. Yet neither direction is more real. Both are expressions of the same cosmic truth. The universe does not promise permanence. It only promises change, somewhere on the other side of the cosmic divide. There may be minds contemplating questions very different from humanity's, not where are we going, but where have we been ongoing? For them, stars are not engines of creation, but vessels returning to fuel. Galaxies are not sprawling systems of life, but memories of complexity that once existed. Civilizations are not aspirations. They are scars, healing into simplicity. To them, the Big Bang is not ancient history. It is destiny. Humans fear the unknown that lies ahead. Backward beings fear the unknown that waits behind. Their future collapses into origin. Our past fades into mystery. Two directions. Two anxieties, both valid. If forward time celebrates potential, backward time mourns possibility. And yet, if these two realities share a beginning, then they share a connection deeper than physics. They share a cosmic symmetry, a unity hidden beneath opposing directions. Humanity might be the memory they are losing. They might be the prophecy humans fear. Perhaps déjà vu is a moment where two arrows briefly touch, where backward memory meets forward hope. A glitch not in the brain, but in the boundary between two universes. Perhaps intuition. That quiet voice that insists something has already happened is not imagination, but communication. There may be minds, alien or familiar, who know humanity's fate, not because they see the future, but because they remember it. There. Maybe beings for whom Earth's distant tragedy is filed away as ancient history, a history that has not yet unfolded for us. There may exist an intelligence witnessing the death of stars that are still shining in our sky, not with wonder, but with nostalgia. They could watch humanity rise into greatness, then forget greatness, then forget themselves, and as time erases their identity, they may look outward, toward the other universe, toward us, and wonder what direction time is moving there, because to them, we might be the anomaly. We are the ones aging toward knowledge. We are the ones building meaning. We are the ones gathering wisdom instead of losing it. Perhaps they see our existence as miraculous, or terrifying. For in their world, tomorrow is always smaller than today. In ours, tomorrow still holds promise. Across the cosmic void, two arrows continue diverging, one into birth, one into conclusion. One universe writing its story forward, the other reading its story backward. But what happens when stories meet? If the boundaries ever brush together, if forward time and backward time collide, which truth survives? Will the universe choose progression or regression? Will the future triumph over the past, or will the past reclaim the future? Humanity stands on fragile ground, trusting that time is on its side, that existence will continue to build, that meaning will continue to grow. But the cosmos provides no promises, not of stability, not of direction, not of destiny. Time flows, and flow can change direction. Existence continues, and continuation can reverse. Our universe may be a brief experiment in forward motion, a rare flame rising against the current, destined one day to be extinguished back into its origin, or perhaps direction is not choice, but coexistence, forward and backward, not enemies, but partners completing a cycle, beginnings and endings, not opposite, but reflections. Perhaps what humanity calls death is not an end in the forward universe, but a beginning in the backward one, and perhaps what they call death is the birth humanity has not yet reached. Two worlds, one truth. Time is a mirror. Both sides hold light in the hush of the cosmos. In the silence behind the measurements, a final question lingers, gentle yet overwhelming. If time can move backward somewhere, then what direction is it moving for us? Are humans racing toward destiny? Or returning to the start? Is progress creation? Or the illusion of creation? Is the future waiting ahead? Or remembering us from behind? Time does not answer. It only continues. Forward or backward motion remains, and the universe, wide enough for both directions, waits in quiet wonder for humanity to discover which way it is truly going.